Guys, and welcome to my video. Today I'm going to be talking about projectile motion. Have you ever wondered why it is that when you throw a ball, it traces the path of a parabola? So what is a parabolic path? A parabolic path is simply a path which looks like a parabola function when you draw it on the graph. So what exactly is project? To project is to throw, and what is motion? Motion is just motion of a particle. So projectile motion is literally motion of a particle which you have thrown. So how exactly does it work? So when we're talking about projectile motion, we mainly divide an object which we are throwing. Let's say we're throwing at 5 meters per second. We would mainly divide it into the x component and y component and talk about them separately. So how exactly does this work? So let us talk about how this works. In the previous example which we just now took, let us draw the graph for it, x, y. So when we take the 5 meters per second ball, how can we divide this into its x and y components? We can do this by using simple trigonometry. Let us say we threw it at an angle 30 degrees. So we would just simply take as the hypotenuse to be 5 and then divide it by taking the adjacent side is taken as cos. Like how we take cos is equals to adjacent by hypotenuse, the exact same way we take 5 cos 30 and 5 sin 30. By doing this, we divide it into components like this. This is how we get the x and y components. After we get the x and y components, we can talk about them separately. So just for more practical purposes for people to understand, let us say we have a wall over here and we are just leaving a ball, just releasing a ball, and it traces a path which comes down. Now this path, and that is the time taken for the ball to travel the height h, will not depend on the y component. That is, even if you throw it with 100 meters per second, it really doesn't matter. It will take the same amount of time. The x part of the graph, that is the x component, and the y part of the graph functions completely differently. What is time of flight? Time of flight is simply the amount of time taken for the ball to go from one ground to the other part of the ground. How do we derive such a formula? Well, you would notice that the vertical displacement is actually equals to 0, and what is the form? We have a formula for displacement, that is s is equals to ut plus half at square. Now if we combine this with the previous thing, we can get that 0 is equals to u sine theta t minus half gt square. Now why exactly is it minus half gt square? Because by general sign convention, upward is positive and downward is negative. Since gravity acts downwards, usually at least, we put a negative sign. So now we have 0 is equals to u sine theta t plus minus half gt square. Okay, now if we on simplifying this formula, we get t is equals to 2u sine theta divided by g. This is the time of flight formula which we get. Using this, we can solve many complex physics problems which would have taken a lot of time, but since we have this relation, we can solve it quite easily. Okay, so now for a general question, let us say, how can we maximize time? There is time of flight. How can we maximize this? Well, the only thing we can really change about this is u and theta. Well, obviously for the maximum time of flight, we would have to take maximum velocity that we can give. So let us say for an average person, you can throw a ball at, let's say, 10 meters per second. Well, 10 meters per second would be your u max. But what can we really change? That is theta. How exactly can we change theta to suit our needs here? What is sin theta max? Sin theta usually varies from -1 to 1. So what exactly can we do here? We can put 1 to get maximum. If we put something like 1 by 2, obviously we would end up with a result where 2 and 2 would cancel out, and we would get t is equals to u sine, so u by g, which is clearly not the maximum. The maximum is 2u upon g, that is time period. How can we achieve this time period? Obviously sin theta is maximum at 90 degrees, which makes sense because when you throw a ball up, you would notice that that's the maximum amount of time required. What exactly is range? Range is simply what is the displacement of the ball from one point to the other. Not vertical, obviously, because we know vertical is simply zero. What is a horizontal displacement? So how do we get a formula for horizontal displacement? We know very well that gravity is the only force which is acting on this, and that is only in downward direction. So there is really no acceleration that is acting in the left or right direction, unless obviously you account for wind, which let's just say is quite complicated. So even in that case, it's quite easy to derive a formula, but we will just not go into that much depth in this video. If you want it, I mean, I can just do it anytime when required. So let us try to get a formula for this. So when there is no acceleration, obviously we can give s is equals to ut, because the other part of the equation will become 0. So it doesn't really matter. So s is equals to ut. So range is equals to x velocity of this multiplied by time period. That is, from the previous equation we can get that r is equals to u square sine 2 theta divided by g. This is what you get on simplifying this. This will become this. So how can we maximize r? So we know that r is equals to u square sine 2 theta divided by g, which we just derived. Obviously we have just in the previous shown that u is literally whatever you can throw. Your muscles are literally your limitations. Gravity is obviously constant, so the only real thing which can change here is theta. So again, what is theta? Well, some of you might say that sine 2 theta max might be again 90 degrees, but obviously it is wrong, because 2 theta equals 90 degree is will be the max, obviously, right? Sine 90 is max, so 2 theta should be 90, which means theta is equals to 45, which really, when you try to practically do it, it makes sense. The closer you get to something that looks like this as a component, or rather how you throw it, is usually where you get the maximum range, right? If you ever try to throw a ball, it really makes sense, right? The closer you get to this perfect angle, you get the maximum range, right? So that is r max. Now, what is maximum height? Maximum height is not really what is the maximum we can give, what is the maximum you can throw a ball. It's not really about how high you can throw a ball. Obviously, we know that if you throw a ball vertically upward, it will go the highest, right? And we also know that that is what will give you the maximum time of flight, right? So, what am I talking about by H max? Well, when you throw a ball, you will notice that at one point the ball reaches its highest point, and at this point, it is also that the vertical component actually becomes 0, and there is only a horizontal component. Now you might say, oh well, then shouldn't the ball just go like this? Well, that is if you're not accounting for the gravity will continue to act on this, and its velocity will actually go from positive here to negative. That is obviously if you're considering positive as upward and negative as downward direction, which is a general convention. So how can we really get H max? So how we can derive this is actually using a very basic formula, that is v square is equals to u square plus 2as, and I just told you that v square is actually 0 at the highest point, right? So 0 is equals to u square sine square theta minus 2gh. So why am I taking sine theta? Well, obviously because it's a component and sine is the upward component. So that's why I'm taking sine square theta. Now when you simplify this equation, you get that h is equals to u square sine square theta divided by 2g. And this is the formula for h max. So, and obviously this formula makes sense, because when you think about it, sine square theta is again maximum at 90 degrees, and u square is obviously maximum at whatever velocity you're able to throw it maximum at. G is a fixed constant, so it really makes sense as a formula too. Now, well, there's actually a second formula for range. What is this second formula for range? And that is, you might remember about how range is equals to u square sine 2 theta divided by g. We just derived this in the video. So the same, this using this actually we can get that 2u sine theta u cos theta divided by g. When you simplify this using sine theta tan to theta formula, that is sine to theta is equals to 2 sine theta cos theta, and also split the u as u into u, you get u into sine theta and u into cos theta. And obviously from the previous explanation which I told you, we know that u sine theta and u cos theta are simply the components of u, that is 2 into ux into uy upon g. So this is the second formula for range. Now, what is the equation of trajectory? Equation of trajectory is simply an equation given to what trajectory the ball follows. Trajectory is simply a fancy word used for what is the path that the ball follows. So in reality, when we say equation of trajectory, what we mean is, what can you give me a formula for what path the ball follows when you throw it? That is simply equation of trajectory. Now, how can we do this? Using for the previous things, you might realize that x is simply um, ux into t. Ux is simply the x component of velocity. So we can also represent that x is equals to u cos theta multiplied by time, and we also know that y is u y t minus half gt square, which is, now when you simplify the previous equation and remove time, you get y is equals to u sin theta by u cos theta into x minus half g into x by u cos theta the whole square, and you will get the final answer as y is equals to x tan theta minus g x square by 2 u square cos square theta. This is not really that much important of a equation you want to learn, but people might ask you questions based on this, or you might have real life examples where you need to apply this. So well, you can always derive this, I would say, but well, if you want to remember it, you can. From the previous part about this video, uh, you might remember about how I told you it doesn't really matter, or it doesn't really affect the time taken for the ball to go from this point to this point, even if you throw this at 2 million meters per second, or whatever speed of light. Okay, maybe at speed of light it might have some difference, but it doesn't really matter. So how can we prove this through an equation, or rather how to derive such an equation? Well, from the standard formula, S is equals to ut plus half at square, we can substitute minus h is equals to y is h minus, well, because we are measuring h in a downward direction, we are measuring like from here to here, which is negative, and hence y h is negative. Now, how to derive this equation? Let's continue. You will get the ux component, or rather the uy, sorry. You will get uy multiplied by time period plus half gt square, that is g is minus, and when you simplify this, we will get t is equals to root over 2h by g. In this equation which we have derived, you can see that there is no component or anything. It doesn't really matter what velocity you throw like this, what velocity you throw like this. If you're thinking about how this part got removed, well, uy is 0. Since you're throwing it like this, there is no uy component, and even if you leave the ball, again there is no uy component. U equals 0, or at least uy equals 0. Ux can be literally infinity, or rather not infinity, light speed exists. We all know about how that could affect this equation. Well, even if you throw it like this, it doesn't really matter, right? Now, how can we derive a range formula based on the previous equation? We know that S is equals to u multiplied by time when there is no acceleration. Why there is no acceleration? There is no acceleration in this direction. So we can really eliminate that, and we get this formula. From this formula, if we substitute the previous thing, we simply get range is equals to u multiplied by root over 2h by g. And that's literally that simple. Thank you for watching, and if you liked it, like it, I guess. If you didn't like it, don't like it, I guess. That was projectile motion. That's at least how I understood it. Yeah.